All right, today's topic, we're starting slope and rate of change. They're basically the same thing, slope and rate of change. It is the ratio of the vertical up and down change to the horizontal or left and right change. Oftentimes, we see slope referred to as rise, so how far you go up or down, over run, or how far you go left or right. Sometimes they get fancy on us. I don't know why they do it. Sometimes they get fancy, and they would say, like, the change in y, that little triangle means change in x. Just a fancy way to write things. Means the same thing, though. We have 4 types of slope that we're going to see. We should be able to look at a graph and figure out, identify whether it is going to be one of these 4 kinds of slopes. The first one is positive. We always read our graphs from left to right. So if I'm thinking about a positive graph, I want to see it going upwards as I read it from left to right. So something like this. If you're thinking about like how you would read a graph of like a business's sales over time, you know it would be positive if their sales or their amount of money is going up like this, right? That's how we tell something is positive. Opposite to that is a negative slope. So again, reading from left to right, that means that this would be going downwards. So if something is losing a lot of money, you would see that line goes down over time. Those are the 2 big ones. And then we have some weird ones that we see sometimes. The first one is when I have 0 slope. This happens when I have a horizontal line. My slope is literally just 0, that's it. And the other option is when my line goes up and down like this. We call that vertical. Do we know what the slope of a vertical line is? Anybody?
120.
Autumn? It's undefined. So those are my 4 cases. I should be able to look at any graph and be able to tell whether it's positive, negative, 0, or undefined. Sound good? Okay, so we're going to find slopes or rates of changes in 3 different ways. The first one we're going to do it is by looking at a table. This is a table of x and y values. It doesn't say x and y, but we can pretty much assume that x's are on the left, y's are on the right. If I'm thinking about slope, I'm always thinking about the change. Oh, let me not write that so close. The change in the y values. Change in y's over the change in x's. Okay? So first off, let's take a look at this one. This says the table shows the distance a band marches over time. Do we think this is going to be like a positive or a negative? They're marching somewhere. It's going to go upwards, right? My number should go upwards because they're marching a certain distance every minute. So the first thing we need to determine is this constant? Are they going up by the same thing every time? So if I look in the x's, are they going up by the same amount of minutes every time? +1, +1, +1. That's good. Now, are they going up by the same amount of feet every time? How many feet are they going up every single time? So we would call this constant. And if it is constant, we can write its slope. So the slope that we are going to write, aka rate of change, means the exact same thing. The change in the y values we just decided was 260 feet. The change in the x values was 1 minute. So every step they changed 260 feet over 1 minute. Can I write that in words? They march 260 feet per minute. Any questions there? What would be the distance they marched after 6 minutes? How would I find it? James. 6 times 260. Every minute they march 260 feet, so let's multiply that by 6 minutes. I believe I get 1,560 feet. Questions there? Okay, let's do the same thing for the other side. Again, let's figure out, is this constant first? So I'll take a look at my x's. 2 to 4, that goes up by 2. 4 to 5, that goes up by 1. 5 to 7, that goes up by 2. Okay, weird. Doesn't look constant to me. Let's check the other side, though. What am I going up by every step here? What do I go up by? 28 to 56. Yeah, James? Okay, what about this next one? Anybody? What about the next one? So what do we think? Is this a constant rate of change or not constant? What are they going up by every one video game? $14 for one video game. So when they go up by 2 video games, it should go up by double 14, which is 28. So yes, this one is also constant. I could take any sliver here. If you wanted to write $28 over 2 video games, you would just have to make sure that you simplify that in the end. The simplified form should look like y's over x's, $14 per one video game. And again, let's write that in words. It costs $14 per game. Questions? What would be the cost of 8 video games? James? 8 times 14, $112. Beautiful. Any questions? Okay, flip it over. We found slope from a table. Now we're going to find slope from a graph. From a graph, super easy. We're just doing some counting. If I take a look at these graphs, I should be able to tell you whether my slope is going to be a positive number, a negative number, 0, or undefined just by looking at it. What do we think for letter A? Is it going to be positive, negative, undefined, or 0? Cody says this. Do we agree? It's all going to be positive. Take a look at the way that that graph is shaped. If it's going up as we read a book from left to right, then that's going to be a positive. So my slope, or my rate of change, should be a positive number. And if it's not a positive number, we did something wrong. So take a look here. We are counting. I have to pick a point that is on like the corner of a grid box. I'm not going to pick a point that's in the middle of nowhere. This one is nicely highlighted for me. I see 2 points. I'm going to start at the point on the left, like I'm reading a book, left to right. So that point is at -3, 1. Do we see it? I'm looking at this one right here. And basically, I need to change color for that to work. Basically, what I'm going to do is I'm going to count. Another way that we write slope, I wrote it on the first page, is rise over run. So I'm going to count how far do I go up from point A to point B, or maybe it's down. I will count boxes, 1, 2. So this tells me I rise 2 boxes, and then I count how far left or right do I go. I go 1, 2, 3, 4, 5 to the right. There's my slope, 2/5. If that fraction is not simplified, you should be simplifying it. That's all I got to do there. Questions? Okay, look at B. Looking at my graph, is this going to be a positive number, a negative number, 0, or undefined? It's going to be negative. So if my slope that I find in a second is not negative, then I did something wrong. I start with the point on the left, which is that guy right there. I'm first going to count the rise. Now, sometimes my rise is negative. That happens. I go down 1, 2 boxes. My rise is -2. I go over 1, 2, 3, 4, 5, 6 boxes to the right. My run is 6. This is not simplified, so I have to make sure I simplify it. -1/3. My slope is negative, which matches the shape of my graph. I'm good to go. Another one. Positive, negative, 0, undefined. Another -1. The points aren't nicely picked for me, so I have to make sure that I pick 2 points that lie on the corners of my graph. So let's see, this one here, do we see how it lies nicely on a corner? This one here lies nicely on a corner. I'm going to pick the dot that's on the left, which is this guy right here. I'm going to count the rise down, 1, 2. The run over, 1, 2, 3. My slope, -2/3. That's it. Not rocket science here, right? Not telling you anything crazy. Okay. Letter D, what's my slope? 0. Horizontal line, always 0. What about for letter E? James. Undefined, vertical line. Perfect. What about letter F? Read. Another vertical line. I'm going to show you a quick little acronym that doesn't really make any sense, but some of us really like it. It doesn't really mean anything. Ooh. The first part of my acronym says HOI. The H stands for horizontal. The O stands for 0 slope. And I'm going to tell you what the Y stands for in a second. The other half, let's see. Can I fit it over here? The other half, I'll just put it underneath, is VUX, which again does not mean anything. The V stands for vertical. And the U stands for undefined. I literally still use this acronym to this day to figure out which one I'm talking about. Horizontal, HOI, 0 slope, vertical, VUX, undefined slope. I'll tell you what the Y and the X mean in a second. Any questions there so far? James?
I know it has to do with something with the value being 0.
I'll tell you in a second. Don't worry. I'm not going to leave you hanging. Okay, so we have now found slope/rate of change from a table. We found it from graphs. Now we're going to find it from points. So every pair of points, we can draw a straight line through. We can find their slope using just the points. We have a formula. This, unfortunately, is a formula that you just need to have memorized. It says, if I have 2 points, I'm going to call this point right here point 1, and I'm going to call this point right here point 2. Each of them has x and y values. So for point 1, I'll call them x1, y1. For point 2, I'll call them x2, y2. Then I can set them up in this formula. Remember, my change in y's always goes in the top. My change in x's always goes in the bottom. This formula says I take y2 from the second point minus y1 from the first point over x2 from the second point minus x1 from the first point. It is always a minus in there unless you're subtracting a negative number, in which case it would be a positive. But it is always going to be a negative in there when we plug it in. Okay, that's a formula we got to have memorized. No shortcuts. Here we go. I'm going to rewrite it. There's my formula. And then what I do is I label these points right away. Let's call this x1, y1, x2, y2, right? I have point 1 to point 2. I'm literally going to plug stuff in. y2 is 8, y1 minus negative 4. I see that double negative. I want to make sure that I include that double negative. Over x2, negative 9, minus x1, negative 3. Again, a double negative. Simplify. 8 minus negative 4 is the same thing as 8 plus 4. Negative 9 minus negative 3 is the same thing as negative 9 plus 3. And I simplify. Do not leave your fractions unsimplified. So if I saw this, you'd be losing half credit. We have to simplify this to negative 2, I believe. That's it. Any questions for that? Okay, can you help me out with letter B? The top of my fraction, y2 minus y1, looks like what? James. Perfect. The bottom of my fraction, x2 minus x1, looks like what? Autumn? Perfect. 3 minus 2 is 1. Negative 1 minus negative 6, negative 7. That's as simplified as that one can get. Questions on these two? Okay. Letter C. Same thing. The top of my fraction looks like... Oh, I don't want to sit here and stare at you. Somebody tell me what the top of the... y2 minus y1. What is y2 minus y1? Negative 2 minus negative 3. x2 and x1 should look like 4 minus 4. Yes? Simplify this. Negative 2 plus 3 is 1. 4 minus 4. Uh-oh, what happens? I cannot divide by 0. So if I ever am dividing by 0, this is going to be undefined. Let me go back to those acronyms I was telling you about. I'm looking at vertical because that guy was undefined, right? So for a vertical line, this x tells me that the x values are the same. Look at those 2 points we just had. 4 and 4. Those x values are the same. That's a hint to me that this is going to be a vertical line that's undefined. So the same thing goes for the hoi. If my y values are the same in my 2 points, then I'm going to have a horizontal line with a 0 slope. Take a look at letter D. Do we see how these y values are the same? So that's a hint to me that I should be getting a horizontal line with a 0 slope. Let's just check it really quick for fun. Negative 3 minus negative 3. 5 minus negative 1. Negative 3 plus 3 is 0. 5 minus negative 1, which is plus 1, is 6. There it is. 0 over anything is 0. Any questions on that?